So now the next problem is about a AR2 process, and this AR2 process is defined as yt equal to phi 2 yt minus 2 plus epsilon t. So we really do not have a term phi 1 and yt minus 1. So that's a little tricky about this equation. You don't have something which we usually have. But that doesn't make a big challenge for us because it actually becomes like a AR1 process where you have only one term. Only thing is that the term is taken from lag 2. When we are trying to identify the value of phi 2, we don't have to scratch our head. We can simply use the stationarity principle that we have for AR process, and using those principles, we can actually identify the value of phi 2. So normally what we use is we use the expectation term, we use a variance term, we use a covariance term. So let's see what we need for this to solve this particular problem. So if we take expectation on both sides, you will see that if I have expectation of y equal to mu and phi 2, and here also I will have my expectation of y equal to mu, and of course for error term it is going to be 0, so my phi can only have value equal to 0. Okay, so that we know. Now let us look at the variance part. So that's going to be a little interesting. Now if I take variance on both the sides, variance of yt equal to phi 2 square, variance of yt minus 2, then there will be a covariance term which is going to be 0 because my error term is IID, and then I have a variance of the error term square, and let's say here I can write sigma square or I can write it 1 depending on how I have chosen my variance of my error term to be. So here what I will do is if the condition, the stationarity condition is valid, then variance of yt is going to be equal to variance of yt minus 2. So let's say that's my sigma square. Okay, so I'll take sigma square in this side, sigma square 1 minus phi 2 square is equal to 1, or it could have been sigma e square. Okay, so now let's use a different color. So then I have my sigma square is equal to 1 minus phi 2 square, right? Now from this equation we can say that the value of 1 minus phi 2 square, 1 minus phi 2 square has to be greater than 0, right? Has to be greater than 0 because you really cannot have a value which is negative, which you cannot afford to have your denominator negative because your variance term is always positive. So that's ruled out. So that's the condition that you get from here. Now if that is the case, then I have my phi 2 square is going to be always less than 1, which means my phi 2 will have a range of from minus 1, so from 1 to minus 1. So that's basically the range of values for the phi 2, right? So that's what you need for the above process to be stationary. Okay, now let's look at another problem. Now we have two MA processes and MA2 processes, and one MA2 process is have the theta values, theta 1 and theta 2 is equal to 1 by 6, and the other MA2 process has value theta 1 minus 1 and theta 2 6. Okay, now we have to basically say something about the roots of the characteristics equation. Okay, so that's basically we have to say, which means that we have to set the characteristics polynomial for the MA process. So like AR process, for the MA process as well, we have the characteristics polynomial as theta 1 x minus theta 2 x square is equal to 0. Okay. Now let us put the value of theta 1 and theta 2 here for the first process. So let's say this is my equation 1, and now I'm going to put the value of theta 1 and theta 2 from my first MA1 process. So which means 1 minus x by 6 minus x square by 6 is equal to 0, which means I can write 6 minus 3x plus 2x minus x square is equal to 0, which will mean that I can actually have 2 minus x and 3 plus x is equal to 0, which means I can have my value x equal to 2 or minus 3. Okay, so that's from my first MA process. So let's call it equation 2. Now my second MA process is basically 1 minus theta 1 is going to be plus x, and then I have minus 6x square is equal to 0, okay, which means 1 plus 3x I can write minus 2x minus 6x square is equal to 0, okay. Then I can, then it actually becomes very simple. 1 plus 3x is going to be one part of it, and then I have, here I can take 1 common, minus 2x common is equal to 0, which means my x is going to be minus of 1/3, and my x is going to be half, right? So which means if I see my equation 2 and 3, I can write the roots are reciprocal. The roots are reciprocal.